The purpose of this paper is to propose a blueprint for a quantum gravity high maneuvering spacecraft that addresses the reported UAP-5 physical observations as identified by UAPx. The observation of UAPs exhibiting maneuvers that defy current known physics of incredible speeds, instantaneous acceleration up to and more than 50 Gs, and hairpin turns and traveling through different mediums such as air, water, solids, or mountains without having a heat signature and experiencing the devastating G-forces suggest the spacecraft has the ability to manipulate gravity. This would require an onboard gravity generator with the ability for the spacecraft to direct gravity forces to protect and propel the spacecraft for maneuvering. The design and build of a gravity generator propulsion system requires a quantum-level understanding of space-time and gravity. Since there is not a definition consensus of space-time and quantum gravity, I will use as my starting assumption John A. Macken's theory of space-time and gravity as proposed in his papers, Oscillating Space-Time, the Foundation of the Universe, and The Universe is Only Space-Time. So this blueprint for a quantum gravity high maneuvering spacecraft builds off of John's theory of space-time and gravity. I hesitate to call this quantum gravity generator a warp drive, since it implies a possibility to warp space-time to where traveling faster than the speed of light is possible. Perhaps you will agree with my hesitation after I describe space-time along with how the highest gravity object we know, black holes, affects space-time. Here are the 5 UAP physical observables. One has to do with positive lift. It's unknown how lift is generated. The propulsion mechanisms are unknown, and FLIR images show that there is no heat coming out of the UAPs for propulsion. Number 2, their sudden instantaneous accelerations. They have estimated and measured accelerations range from about 70 Gs to over 5,000 Gs. And number 3, the hypersonic velocity without signatures, no sonic booms, hypersonic speeds as high as 46,000 miles per hour, Mach 60, and appears to have a plasma beam ahead. Number 4 is a trans-medium travel through air, water, solids, like mountains. And number 5, it has low observability or cloaking. Not only does a blurred object appear to change size, it also almost disappears, sometimes surrounded by what appears to be a plasma sheath. And it can be optically distorted, difficult to obtain clear images, refraction, gravitational lensing, and often associated with strong electromagnetic fields. These fields can adversely affect electronics in airplanes and other vehicles. So this paper will address every single one of these as we go through it. First, I want to talk about John Macken's oscillating space-time and gravity, which is a critical assumption before we can even go further into building this type of gravity generator. So John proposes a unified theory of physics based on the assumption that the universe is composed solely on four-dimensional space-time, which is length, width, height, and time, with all matter, energy forces, and fields being manifestations of its properties. His theory aims to bridge gaps between general relativity and quantum mechanics, emphasizing the significance of vacuum energy he calls oscillating space-time, and understanding the fundamental nature of the universe. It integrates quantum mechanics and general relativity, offering a conceptually understandable framework for the theory of everything. Oscillating space-time is visualized as a quantum mechanical sonic medium, which is a wave-propagating medium, made of Planck-length oscillations at Planck frequency. These oscillations impose a local rate of time and generate the constants like the speed of light, gravitational constant, and the reduced Planck constant. It is suggested that oscillating space-time serves as a fundamental field that creates and unifies everything in the universe. The various fields in quantum field theory are seen as lower frequency resonances of the oscillating space-time. An electron is theorized to be a rotating dipole wave, which he calls a Saltime wave, within the medium. The oscillation frequency measured locally, which is the same gravitational field, always equals Planck frequency. So as you notice, the oscillations as they're broken down, we have each oscillator changes in volume. So the changing volume has to do with our three spatial dimensions, and the frequency that these oscillations change, which is Planck frequency, is your time. So this is how space-time is related together in the universe. Some characteristics of oscillating space-time include this determines the speed of light. Oscillating space-time Planck volumes, which are the three spatial dimensions at Planck frequency, which is time, ties space and time together and determines the speed of light at approximately 301 million meters per second, which is the speed of light equals Planck length times Planck frequency. The oscillating Planck volume and Planck frequency are reduced by gravity and the material's index refraction of a medium it is traveling through, like glass or water. This causes oscillating space-time oscillators, rate of time, which is oscillating frequency, to decrease, and oscillating volumes, which are the three spatial dimensions, to contract. To decrease, which also affects the speed of light, to decrease, and forces and energies to decrease. Note that when the measuring equipment that has an oscillator clock, which is in the same gravitational field or the same index refraction medium, then the speed of light will always measure constant. Number two is the space-time has curvature. Massive objects curve oscillating space-time, altering the path of objects and light. This leads to gravitational lensing, where light bends around massive objects. This provides a quantum-based rationale for the curvature of space-time, connecting general relativity with quantum mechanics. And number three, elasticity. Oscillating space-time is often likened to a rubber sheet that can stretch and bend. Its elasticity allows it to be influenced by energy and mass, causing it to warp and stretch in response to matter. This means it has the ability to absorb energy and return energy as a wave propagates through the medium. Number four, it's a nonlinear medium. Viewed as a nonlinear medium, oscillating space-time, meaning its properties change to the presence of energy and mass. This nonlinearity is responsible for the creation of particles and forces, including gravity. And it has a single, number five, it has a single relativistic force. All forces, like the gravitational, electromagnetic, strong, and weak forces, are manifestations of a single relativistic force. Relativistic force refers to the force experienced by an object moving at speeds close to the speed of light, necessitating modifications to classical mechanics to account for relativistic effects. Here's a simplified model of an electron that produces electromagnetic waves in a gravitational field. So the rotating electron, which is a dipole core, modulates or distorts space-time in four dimensions: three-dimensional volumetric, Planck length, and modulation of space-time, and also modulates rate of time. The difference in rate of time between the core lobes creates a rate of time gradient strain within the electron core. This rate of time gradient produces acceleration, which is directly related to the electron creating gravity. Space-time interaction with the electron spinning core creates a rotating standing wave. The rotating standing wave creates electromagnetic waves from a primary distortion in space-time as a linear effect that scales with amplitude. And gravity is created by the second-order distortion in space-time as a nonlinear effect that scales with amplitude squared of the electrostatic field. And if you want to learn more about this and refer to the references at the end of this paper that will describe oscillating space-time and how an electron creates electromagnetic waves in further detail, along with gravitational fields and much more insights to our universe. So understanding gravity effects on oscillating space-time. In this illustration, we know that gravity slows the rate of time. We can reference gravitational time dilation for that. What may not be as obvious in keeping with the laws of physics is that a slower rate of time slows time, the oscillating frequency of the space-time oscillators, and reduces space, which is the volumes of the space-time oscillators that affect the three spatial dimensions, which are length, width, and height. Both space and time change proportionally so that an observer or measuring equipment in the same gravity field will not notice or measure a change, so everything stays constant, including the speed of light. However, from an outside observer in a different gravity field would see a change in space-time as gravity changes. The following is a list of some changes that occur when gravity field increases. The rate of time decreases. This is what actually creates the redshift. The three spatial dimensions get smaller, which is the length, width, and height. The speed of light decreases, and the energy of matter, such as an electron, decreases. So here's a fun note, little side note on here, that what if just after the Big Bang, when all matter, energy forces, and fields were beginning to form, there was an additional force that also began that created a gravitational force that was not created or not created from matter. This gravitational force, called background gravitational gamma, is homogeneous throughout the universe and is constantly increasing with time. This force affects the space-time oscillators the same way that gravity from a mass does. Time slows and the three spatial dimensions, length, width, and height, get smaller. This would still create the same cosmological redshift that has been interpreted to mean that the universe is expanding and continuously creating new space, when in actuality, the universe is not expanding. We are actually shrinking over time due to this gravitational gamma. This would not require the mysterious dark energy and that no one can explain, but it's required to balance equations to account for an expanding universe. So now let's move on to how a mass affects oscillating space-time. Gravity created from a mass has acceleration, meaning that gravity effects get weaker the further away from the mass. Here is an example of a mass affecting space-time oscillators where the gravity effects closer to the mass have slower frequency and less volume than the oscillators further from the mass where the gravitational force is less. So our higher gravity space-time oscillators, which are smaller, the closer it gets to the mass, the yellow would be the slowest rate of time, more gravity, and then the red would be less gravity, and then the blue would be even less gravity affected by the mass. And now let's look at a black hole and how a black hole affects oscillating space-time. Black hole and oscillating space-time most likely creates the highest gravity that space-time can handle without the rate of time completely stopping. If gravity forces become so large that oscillating space-time stops oscillating, which means time stops, and oscillating volumes contract to zero, which means no spatial dimensions, then there will no longer be a wave propagating medium to support waves, particles, and forces, including gravity. So everything would break down. So perhaps just prior to this point of space-time total breakdown, oscillating space-time triggers the emission of gamma rays, which prevents this breakdown to occur that we do see coming from black holes. So let's do some couple of thought experiments on unequal gravity around a mass. So we know that mass warps or curves space-time, and here's the 360-degree warping around a mass, which is the image on the left. And if our thought experiment removed all gravitational fields created by the upper half of the sphere, then only the lower half of the sphere would create a gravity force curving space-time, with the sphere having a higher gravity field on one side than the other side. The sphere would move towards a stronger gravity field, which is the lower rate of time. So in this case, it would be moving downward. And here's another thought experiment with the following ball with and without an added gravity force. So this shows what would happen between a ball with and without an additional gravity field above the ball. The ball on the left will accelerate towards the stronger gravitational field of the Earth. This acceleration is determined by the difference in gravitational strength rate of time on either side of the ball. The ball will seek a position where the gravitational forces balance out. If the forces remain uneven, the object will continue to move toward the stronger pull of the Earth's gravity, which is lower rate of time, until it reaches a new equilibrium or is constrained by other forces like hitting Earth, the land. Now, on the right, the ball on the right, assuming we had the technology to place a directed gravity field above the falling ball that is equal but opposite in strength to the gravity of the Earth, then the ball would just hover. It would not fall. So it would neither move up nor down. Now let's look at the concept of a model of a quantum gravity generator with output control. So in this illustration, here's a concept model of a quantum gravity generator module with output control. The output is controlled by the gravity output control, which adjusts the modulator valve to increase or decrease the level of output gravity field level and electromagnetic fields. The strength of the gravity field is conceptually modeled by a gravity well, where the size of the gravity well indicates the strength of the gravitational field. It is proposed that the quantum gravity generator could use electrons or muons to create electromagnetic waves and gravity. Even though a muon is about 207 times heavier than an electron, would create more gravity. The muon is unstable with a lifetime of about 2.2 microseconds, while an electron has a lifetime of about 26,000 Yoda years, which is at least 5 quintillion times the age of the universe. Electrons can be sourced several ways, including from the outer electron shells of atoms, while muons can be sourced several ways, including using ultra-short, high-intensity lasers capable of accelerating electrons to giga-electron volt energies. The quantum gravity generator, whether using the muon or electron or something else, would need to create enough electromagnetic wave amplitude and gravity field to propel a spacecraft through space-time that would address the UAP5 physical observables as identified by UAPx. An understanding of quantum gravity and oscillating space-time is a critical beginning. To build this quantum gravity generator will require a paradigm shift in thinking among physicists and require a large advancement in physics to occur. This is beyond the scope of this paper, however. Now let's move on with our concept of a quantum gravity generator, but we will now provide multiple outputs. So a directional control module would be added to the output of the quantum gravity generator module for multidirectional control. The directional control module has a directional valve control that independently controls each directional modulator valve to modulate the individual level of gravity field and electromagnetic waves for each output. The gravity output control in the quantum generator module controls the total amount of power to all outputs at once. Now let's look at a concept model of our quantum gravity high maneuvering spacecraft. So here's a concept model of a quantum gravity high maneuvering spacecraft. It is proposed that the spacecraft could be any shape and built out of materials similar to the space shuttle, including the thermal protecting system on its exterior or perhaps a ceramic material composite. It should have enough gravity directional output ports on its exterior to be able to fully encapsulate the spacecraft with a variable gravity field and to steer the spacecraft in any direction through space-time. These ports would be connected through tuned waveguides connected to the directional control module and quantum gravity generator module. The spacecraft would have a command center, either remotely controlled, AI controlled, or pilot controlled, which could be human or non-human. There would be two major controls in the command center for gravity field control to the output ports. One major control would control all the outputs of the quantum gravity generator module for increasing or decreasing the gravity field to all output ports that would surround the spacecraft. The other major control would control each individual output ports by the direction control module, which would take care of maneuvering the spacecraft. Now, here's a spacecraft that is fully encapsulated with gravity and electromagnetic waves. So here's an illustration of control inputs into the quantum gravity generator module, which is the red dotted arrow on this one. The quantum gravity generator module adjusts the gravity field and electromagnetic field waves to all individual output ports equally. This provides for encapsulating the spacecraft in a gravity field and electromagnetic field waves. The gravity field that fully encapsulates the spacecraft could have the following effects. Number one, it could protect the spacecraft and any component and any occupants inside during high G maneuvers by controlling gravity force inside the spacecraft at safe levels. It could deflect potential threats such as space dust, meteorites, Hellcat missiles, and etc. from making contact with spacecraft by causing the threats to follow the curvature of space-time around the spacecraft in a high gravity field. You can reference the geodesics on that. And it would allow movement through different mediums such as air, water, solids by curving space-time around the spacecraft, which also allows for silent hypersonic speed, and changing the physical size of spacecraft by increasing or decreasing overall gravity field. Remember, increasing gravity shrinks everything. Number two, it would create gravitational lensing. You could see images behind the spacecraft by causing the path of the light to be visibly bent around the spacecraft, and it could create what looks like multiple images, distortion of the spacecraft, and could appear spacecraft is surrounded by a plasma sheath. And number three, it could create redshift due to the speed of light slowing and energy decreasing. So here is an illustration of control inputs into the direction control module, which is now moved, showing the red dotted arrow. The direction control module adjusts the gravity field and electromagnetic field waves to each individual output port. This provides for maneuvering aircraft. This image has a control set to accelerate spacecraft to the left by increasing the gravity field to the appropriate individual output ports. In this case, to move left, but you still have the gravity fields encapsulating the full spacecraft. Okay, now this is what it would look like in space-time, the oscillators. So here is an illustration of the spacecraft gravity output ports affecting oscillating space-time oscillators. The red oscillators are controlled by the output of the quantum gravity generator module, and the yellow and green oscillators are controlled by the output of the direction control module, which will move the spacecraft to the left. So you notice the green oscillators are smaller, so that's a higher gravity source. It's a slower rate of time. And then the yellows are next, and then the red ones would be the gravity field encapsulating the spacecraft, and then the blue oscillators would be the lower gravity oscillator. Okay, now we're going to look at how the gravity curves space-time. So it's proposed that a strong gravity field output from the spacecraft would allow for transitioning and maneuvering in different mediums such as air, water, solids by curving space-time. This strong gravity field causes matter and light to follow the natural path in curved space-time. And we would reference general relativity, geodesics, and gravitational lensing in this case. In addition, this gravity field will also deflect potential threats, space dust, meteorites, Hellcat missiles, from making contact with the spacecraft. Also, by changing the strength of the gravity field around the spacecraft would change the physical size of the spacecraft. So let's okay, so we're going to look at what the gravity around the spacecraft might look like in different maneuvers. So we have the illustration of some basic maneuvers by directing different gravity field strengths to the appropriate output ports. So hovering in the Earth atmosphere, net gravity force above the spacecraft equal to Earth gravitational field at that altitude, and it would cause the type of hovering situation and not falling down Earth. Moving left in Earth's atmosphere, you would have a net gravity force above the spacecraft equal to the Earth gravity field that would hold the same altitude, and then a net gravity force to the left of the spacecraft, which would move the spacecraft towards the left. Slowing down in Earth atmosphere, we'd have the net gravity force above the spacecraft equal to Earth gravitational field to hold altitude, and a net gravity force to the left of the spacecraft, moving the spacecraft towards the left, and we would have a net gravity force to the right of the spacecraft, and that would be slowing the spacecraft down, counteracting the forward movement of the gravity. And moving right in Earth atmosphere, that gravity force above the spacecraft would be equal to the Earth gravitational field if you want to stay at the same altitude, and the net gravity force to the right of the spacecraft, moving the spacecraft towards the right. Then we have moving up in Earth atmosphere, that gravity force above the spacecraft overriding the Earth's gravity field at that altitude. So you have even more gravitational output force above the spacecraft. Moving slow into a mountain, the net gravity force above the spacecraft equal to Earth gravitational field at that altitude would hold the altitude of the spacecraft. The net gravity force left the spacecraft at a maximum to curve space-time for entering the solid or the mountain. So we would want more gravitational force to the front to allow for the solid to make room for the spacecraft to go through to warp the solid. And then we'd have a net gravity force of the spacecraft slowing the spacecraft down as required. So the force on the gravitational output force on the right would control your speed. You'd probably have to have, but again, you'd have to have more force to the left to provide more curvature to allow the spacecraft to go through the mountain or the solid. Now, moving slow into water, that gravity force above the spacecraft slowing the spacecraft down as required, but the net gravity force below the spacecraft at maximum to curve space-time for entering the water. And then reducing the size of the spacecraft, then you would want all gravity output ports surrounding the UAP or the spacecraft to be equally, but the smaller you want the spacecraft, then the more equal gravitational force that you would want to come out of all the output ports. That would give you the smaller physical size. So let's just take a quick look at the alleged Hellfire missile fired at the UAP off the Yemen coast, October of 2024. Here, that you see the Hellcat missile prior to the impact on the first image, and then the Hellcat missile after the supposedly impact beyond the UAP, and then we have circled the three fragments that we see. So it's proposed that the Hellcat missile did not make contact with UAP due to geodesics, or the gravity that's around the spacecraft. The Hellfire missile has a crush fuse and should have exploded if it made contact with UAP. If there was a strong gravity field around the UAP, then the missile would have been deflected around the UAP by following the natural path in curved space-time, again referencing general relativity geodesics. After the Hellcat missile was deflected by the UAP gravity field, it appears that three additional fragments separated from the UAP but stayed with the UAP. Three additional fragments appears to be all identical, possibly caused by sensor artifacts or gravitational lensing that can cause multiple images. Possible reason for UAP looks distorted due to an increase in gravity field around the UAP. This is just some possibilities. So, summary that this paper has proposed a conceptual blueprint for a quantum gravity high maneuvering spacecraft that is powered by a quantum gravity generator with the capability of high complex maneuvering in space time that has the ability to meet all of the reported UAP-5 physical observables as identified by UAPx. The observation of UAPs exhibiting maneuvers that defy current known physics of incredible speeds, instantaneous acceleration up to 50 Gs, and hairpin turns and traveling through different mediums, air, water, solids, mountains, without having a heat signature and experiencing the devastating G-forces suggests a manipulation of gravity. The challenge is to acquire the technical knowledge and advanced research in physics needed to build a quantum gravity generator that creates enough electromagnetic wave amplitude and gravity field strength to propel a spacecraft through space-time at the extreme speeds and the maneuvers that would address the UAP-5 physical observations as identified by UAPx. Then I have the references listed at the end of the paper. I will provide a link on my YouTube to where you can access this paper. So thank you for listening. Always interested in any comments. I don't claim this is 100% accurate, but I have not seen anything else that can explain the UAP maneuvers. But if there's anything better, please let me know. Thank you. Bye.